and welcome to this video on recursion theory. In this video we're going to be going over a little bit about what is recursion as well as how can we use it. So recursion is a way of writing programs or solving problems where a method can call itself to solve the problem. It's a way of breaking a problem down into simpler problems and using those simpler problems to solve the ultimate bigger problem. In order to do this, what we do, we have what we call a base case and a recursive case. So if you're solving a problem and the function is calling itself, at some point the function has to return an answer. It can't just keep calling itself on forever. So the part where it returns the answer we call the base case, and the part where it calls itself we call the recursive case. So every time it calls itself on the memory stack, you get a whole new execution environment, new parameters, new local variables, and you'll see in a second what that looks like. So here's an example. In this case, it's a recursive sum function. So it's going to sum all of the values from 1 up to and including number, or num, whatever's been passed here. So we set up a result value, and then this part, if number is equal to 1, we're going to set result equal to 1. This would be the base case. So notice we're not calling sum again in this section. So in this case, result equals 1, and we're just going to return 1. In every other case, so 2, 3, 4, 100, whatever, we're going to end up in the else. And in the else, result is set equal to the current number plus the sum function of 1 less than number, the recursive case. So when we look at this, we're going to see how that builds up. So here's that exact same code with the information. We have the recursive case, we have the base case, and we're going to look at finding the sum of 3. So what happens when we call the function with sum 3? A number will be set equal to 3, and in this if-else, it's going to end up in the else, and result will be equal to 3 plus sum of 3 minus 1, which is 2. So this sum call is going to happen now, and that's going to be a call to the sum function with a 2. Number equals 2 for this function. Again, 2 is not equal to 1, so we end up in the else, and we get result is equal to 2 plus sum of 2 minus 1. Now we made a call with the sum value of 1. So what is the sum of all the values from 1 up to 1 inclusive? And the answer to that is num equals 1. This is going to test true. Num is equal to 1. So we're going to have result set to 1. This function is going to return that 1. So we've been building up on the memory stack new copies of data. This function actually returns 1, which is going to go into that sum of 2. So now we have this is 1, 2 plus 1 is 3, and we're going to return that 3 to here, and as we do that, these functions are going to disappear, and that memory data, the data set up in that memory, is going to be freeable by the Java garbage collector. So down here, 3 plus sum of 3 is going to give us, this 3 is going to be here, so it's 3 plus 3, so that's 6. And that's the sum of 1 plus 2 plus 3. It's kind of a complicated way to do it. In this case, you can see how iteration or looping might have been a logical way to solve the problem. Whenever we look at these cases, we need to talk about that base case, that returning 1. If we didn't return 1, sum would keep calling sum, forever until we crashed our memory. That's where we get a Stack Overflow error. Stack Overflow is a real error that you can get. That's where the website gets its name. So this idea is called infinite recursion, and it's similar to an infinite loop. But it will crash much faster because every time you call the function, you add the function and its variables to the memory, and you're going to very quickly run out of memory. So anything that's done recursively can be done with a loop. It can be done iteratively, but we're always going to use recursion when it makes the problem easier to understand. So when we're looking at sum, it probably makes more sense to do iteration, honestly, but it was a really good example for breaking down how recursion works. For other problems like the Fibonacci sequence, where a value is equal to the sum of the 2 previous values, it makes sense to call the function because if I tell you the Fibonacci value of 4, the Fibonacci value of 5, you can easily find the Fibonacci value of 6. When we write recursion, It's a little bit hard to wrap your head around, but the one thing you need to do is when you set it up, you set up the base cases and you set up your recursive call. And what you have to do when you're setting up your recursive call is convince yourself, say, I trust that my function does what it's supposed to do. So I don't need to worry that it's doing the correct thing at n minus 1. When I'm writing n, I'm going to trust the function will do it correctly. So the idea is you assume the function works when you call it, even though you're programming it within the function, which is a little bit of a weird way to wrap your head around. And for some people that makes total sense. And for some people, recursion can be quite difficult for them to comprehend. It's probably considered one of the most complicated concepts that we see in programming. And that's a little theory of recursion.